All right, welcome back, everyone. I'm super excited to jump right into this explainer because today we are totally geeking out on the Bombardier Q400. We're going straight to the manual to break down the sheer engineering brilliance behind its pneumatic and mechanical door systems. We're going to look at exactly how they work, how they keep us secure, and, critically, how they respond during an emergency. So here is our flight plan for today. We'll start with the cabin configurations, check out the flight compartment door, step out to the passenger air stairs, walk back to the aft and baggage doors, and finally decode the door warning systems. Let's get into it.
First up, Section 1, Q400 Cabin Configurations. Okay, so the Q400 isn't just a one-size-fits-all kind of deal. It's highly adaptable. Look at the basic setup. That gives you 74 passengers, 3 standard doors, and 1 Type 2/3 emergency exit. But things get really interesting when you shift to the extra capacity layout for 86 passengers. To fit those extra seats, they actually remove the forward baggage compartment. And crucially, that forward baggage door, it gets reclassified as a ditching emergency exit. Because of that swap, the existing right-hand Type 2/3 exit is completely disabled, literally hidden behind the interior panels. Finally, you have the passenger cargo combi configuration. This one drops occupancy down to 50 passengers, utilizing 2 Type 1 forward doors and 2 completely new Type 3 exits right in the aft cabin.
Moving right along to Section 2, the flight compartment door.
It's honestly fascinating how many layers of heavy-duty security are packed into this one single doorway. This fortified door opens aft, and yeah, it meets incredibly strict ballistic and intrusion requirements, but it also has to manage sudden pressure changes. If there's a rapid decompression, a barometrically actuated lock instantly releases a vent panel on the lower half of the door, letting it drop forward and down to equalize pressure. For physical security on the inside, pilots have a slide latch and a heavy-duty deadbolt. And the visual indicators are brilliantly simple, you know? An unlatched deadbolt means you see 2 red dots. Fully locked and latched, 2 green dots. And at that point, key access from the cabin is 100% disabled.
So, the flight crew controls all this from an overhead remote access system panel. They've got 3 modes: UNLK to just instantly pop it open, deny to lock everything down, and auto. Auto is where it gets really clever. Say the flight crew becomes incapacitated. The cabin crew can go to their own panel in the cabin and request access. That triggers a very tense 40-second sequence. Up in the cockpit, an auto UNLK light pops on and a continuous caution chime starts sounding. If the pilots don't physically hit that deny button within exactly 40 seconds, the door automatically unlatches so the cabin crew can get in and help. Now, what if the cockpit door gets jammed? It has to be manually removed from the inside, and there's a very strict 5-step sequence in the manual to do this. Imagine you're standing inside the Q400 cockpit looking at the door. Step 1, focus on the bottom hinge. You unlock it by rotating the bail outboard and then push or step down on the bottom hinge pin to retract it. The big caution here, you absolutely must release this bottom pin first. Just remember the memory aid, bottoms base. Always start at the base to build your escape route. Okay, step 2, look up to eye level at the top hinge. You're going to unlock and pull down the upper hinge pin. The trick here is pull the peak, reach up to the peak and pull it down. Step 3, drop your eyes to the middle hinge. Unlock it and lift the middle hinge pin up. Think lift the middle. It goes upward, the exact opposite of the top pin. Step 4, with all the pins out, push the flight compartment door right at the hinge side. And heads up, this might require a seriously large amount of force. Remember to heave the hinge. Apply that force exactly where those pins used to be. Finally, step 5, rotate the entire door counterclockwise and stow it against the lavatory wall. Keep in mind, it might just fall straight backward, flat onto the floor. Think swing to the sink. Turn it toward the lavatory so you keep the cabin path clear.
All right, Section 3, Passenger Air Stair Operations.
Over on the left side of the fuselage, we have the primary passenger air stair door. To keep the cabin pressurized and prevent any leaks up at altitude, there's a specialized seal around the door that is actually inflated by air pressure from the airframe's de-ice system. It's a really neat crossover of systems. And get this, even if both engines are completely shut down, there is a hidden reserve tank under the floor that holds enough pressure to inflate and deflate that seal for 4 full door opening and closing cycles. Plus, if the plane ever has to make a water landing, this door has a built-in 16-inch composite ditching dam. It pulls right down from the ceiling on tracks and latches to the floor, literally acting as a wall to keep water from flooding into the cabin.
Directly across from the air stair on the right side is the forward emergency exit, and its operation entirely depends on your environment. If you're on dry land, you operate the handle normally, and the whole door pops open fully as a standard Type 2 exit. But if you are ditching in water, there's a specialized handle you turn to activate a ditching mode. This mechanical shift is brilliant. It ensures only the upper plug-type portion of the door releases as a smaller Type 3 exit. That way, the lower half stays firmly sealed against the waterline. Let's move to Section 4, Aft and Baggage Doors. Now, this translating aft passenger door is super unique because it requires a precise mechanical sequence just to open it. It doesn't just swing, it translates outward and then forward. Here's the strict three-step opening sequence. Step 1. Focus on that internal handle. First, you just pull it. Remember, pull to prompt. Pulling it prompts the opening mechanism to wake up. Step 2. Rotate the handle to unlock the door. Think rotate to release. Turning it frees up the heavy internal lock. Step 3. Rotate the door out to its locked open position by moving it outward and forward. Your memory aid here is swing to secure. You move the translating door outward until it clicks securely into that open lock. And to securely close that exact same door, we follow a strict reverse sequence. Step 1. Focus on the open lock lever mechanism. First, release the open lock lever. Think free the frame. Releasing that lever lets the door move out of its secured open state. Step 2. Rotate the door back to the closed position, physically swinging it backward and inward right into the fuselage frame. Just remember, bring it back. Rotate the door backward into the aircraft body. Step 3. Rotate the internal handle and push it flush to lock everything down. Remember, twist and tuck. You rotate the handle and tuck it in so all the locks fully engage. Heading further back to the cargo areas, these baggage doors are strictly operated from the outside, using external T-handles. There are absolutely no internal handles back here. The forward baggage door actually has a really funky movement. It opens inward and upward first, and then translates outward and forward parallel to the fuselage. The aft baggage door, on the other hand, is a bit simpler. It just swings outward and upward on a top hinge and gets propped open by a telescopic strut. But what's crucial to note is that the aft baggage door uses the exact same inflatable, de-ice-powered door seal that the main passenger air stair door uses. Finally, Section 5, Door Warning Systems. So, proximity sensors on every single passenger and baggage door are constantly pinging data back to the proximity sensor electronic unit. When you look at the pilot's multifunction display, a properly closed and locked door shows up as a nice, reassuring green empty rectangle. But if a door is open or unlatched, boom, it instantly changes into a solid red-filled rectangle with a bold red T1 font telling you exactly which door it is, like packs or baggage. And if the sensor system itself happens to fail, you'll get a global white invalid data message right there on the screen. Now, if any fuselage door somehow becomes open or unlocked while the aircraft is operating, it doesn't just quietly change color on a screen. A rigorous sensory escalation kicks in. The fuselage door's warning light starts flashing, the master warning switch light flashes, and 3 sharp, unignorable tones blast over the flight compartment speakers. And here's the kicker. Even if the pilot hits the master warning light to silence the audio, that fuselage door's light stays solidly illuminated until the door is physically locked again. Before we wrap up, we have to talk about one absolute, non-negotiable operational limit printed right in bold in the manual. Do not operate external doors if wind speeds or wind gust speeds are greater than 65 knots. I mean, think about it. For all these sophisticated pneumatic seals and translating mechanical hinges, Mother Nature still has the final say. Trying to operate these massive surface area doors in wind gusts over 65 knots risks causing severe, irreversible mechanical damage. We've covered a lot today, right? We've mapped out ballistic cockpit doors running on 40-second timers, air stair doors with 16-inch ditching dams and 4-cycle pneumatic reserves, and some seriously strict mechanical hinge sequences. So the next time you step onto an aircraft, I want you to ask yourself, with all these proximity sensors and hidden safety protocols functioning flawlessly in the background, just how much of this incredible engineering is actively keeping you safe without you ever even noticing? Thanks for joining me on this explainer, and as always, stay curious.